Welcome back to Reality Glitch, where today we venture into the mind-bending realm of pure mathematics, a place where logic can lead to conclusions so bizarre they feel like glitches in reality itself. We're tackling a concept that has baffled and intrigued mathematicians for a century, the Banach-Tarski Paradox. Prepare yourselves, because this idea suggests something seemingly impossible, that you can take a solid sphere, cut it into a finite number of specific, unimaginably complex pieces, and then, by simply rotating and reassembling those pieces, create two identical copies of the original sphere. Yes, you heard that right. No stretching, no adding new material, just cutting, moving, and rotating. It sounds like a magician's trick, a con artist's scheme, or something out of an alchemist's fever dream. How can something be duplicated out of nothing? This paradox flies directly in the face of our everyday intuition about volume and conservation of matter. If you cut up an apple, you can rearrange the pieces, but you can't end up with two whole apples. So what's going on here? The key lies in the nature of the pieces and the mathematical framework in which this paradox exists. We're not talking about simple, everyday cuts you could make with a knife. The pieces involved in the Banach-Tarski decomposition are non-measurable sets. These are sets of points so incredibly complex, so infinitely scattered and intertwined that they don't have a well-defined volume in the traditional sense. Think of them as clouds of infinitely fine dust, so intricate that our usual methods of measuring size break down.
The paradox relies heavily on a mathematical concept called the axiom of choice. This axiom, a fundamental assumption in set theory, allows mathematicians to make an infinite number of arbitrary choices simultaneously. It's what permits the construction of these bizarre, non-measurable pieces. Without the axiom of choice, the Banach-Tarski paradox simply doesn't hold. It's a purely mathematical truth, existing in the abstract realm of formal systems, not necessarily a blueprint for physically duplicating gold balls in your basement, much to the chagrin of aspiring alchemists.
Imagine trying to describe one of these pieces. It wouldn't be a wedge or a slice. It would be an infinitely porous collection of points, so holy and wispy that our physical intuition fails us. The process of cutting the sphere is a conceptual division into these abstract sets. Then, through a series of rotations and translations, sliding them around without changing their shape or size in a mathematical sense, these ghostly, perforated pieces can be rearranged. Because they are so strange and lack defined volume, they can be interleaved and shifted in such a way that they fill the space of two spheres identical to the original. It's crucial to understand that this is a paradox of measure theory. It highlights the limitations of our intuitive understanding of size when dealing with infinitely complex sets in three-dimensional Euclidean space. It doesn't violate any laws of physics because these mathematical cuts and pieces are not physically realizable. You can't hold a non-measurable set in your hand. The atoms that make up a physical sphere are finite and discrete, not the continuous, infinitely divisible points of pure mathematics.
So, what's the glitch here? It's a glitch in our intuition, a point where the abstract world of mathematics diverges spectacularly from the physical world we experience. The Banach-Tarski paradox forces us to confront that the fact that mathematical truths can be deeply counterintuitive. It shows that concepts like volume
or size, which seem so straightforward, become incredibly slippery when we delve into the foundations of set theory and the nature of infinity.
While you can't use it to solve world hunger by duplicating loaves of bread, the paradox has had profound implications within mathematics itself. It spurred research into measure theory, the foundations of mathematics, and the role of axioms like the axiom of choice. It serves as a stark reminder that the universe of mathematical ideas is far vaster and far stranger than our everyday experience might lead us to believe. It's a beautiful, unsettling testament to the power of abstract thought to uncover realities beyond our immediate grasp. The Banach-Tarski Paradox is like a perfectly logical, mathematically sound piece of surreal art. It follows all the rules of its system, yet produces a result that makes us question the very nature of those rules and the reality they describe. It's a beautiful monster, born from the depths of human intellect, forever challenging our perception of what it means for something to be and to have size.
A sphere that duplicates itself, a mathematical sleight of hand, or a glimpse into the bizarre nature of infinity. What other mathematical paradoxes make your brain glitch? Share your mind-bending favorites in the comments below. Don't forget to like, subscribe, and prepare for more reality-bending explorations with us at Reality Glitch.